All right, hello again. Now we're going to be doing problem 1.2 of Griffiths Intro to Quantum Mechanics 3rd edition. Problem 1.2 asks us in part A to find the standard deviation of the distribution in example 1.2. And the probability distribution is given by this function. You can see this in example 1.2 and how Griffiths derives this. And we're going to need to find the standard deviation of this. So to find the standard deviation, we use this equation. And first, we're going to need to find the expectation value of x squared and the expectation value of x quantity squared. So first, let's find the expectation value of x. This is given by the integral of x rho x dx. And outside of this range right here, rho of x is 0, so this integral goes from 0 to h. So let's just go ahead and plug in rho of x. We get x times 1 over 2 root hx dx, and we can go ahead and pull out the 1 over 2 root h, and then we're going to be left with the integral from 0 to h of x over root x dx. And you can see that that's just x to the first power times x to the minus 1/2 power, which yields x to the 1/2 power. So this is just going to be the square root of x dx. So now integrating this, we just get 1 over 2 root h, and then you're going to get a 2 over 3 x to the 3 over 2 evaluated from 0 to h, and we can go ahead and cancel this 2 with that 2. So we're going to be left with 1 over 3 root h times h to the 3/2 power minus 0. And then the h's cancel like this, h to the minus 1/2, and you just get h. So you get h over 3 as the expectation value or the average value of x. And now to find the expectation value of x quantity squared, we just simply square this, and we get h squared over 9. So that's the first part to finding the standard deviation. Now, for the next part, we need to find the expectation value of x squared, which is given by this integral, rho of x dx. So now we'll just plug everything in. I'm going to pull out the 1 over 2 root h. This is an integral from 0 to h of x squared over root x, which, once again, if you just do this simplification here, this is x to the minus 1/2. So you're going to get 4 over 2 minus 1 over 2, or 3 over 2. So you get 1 over 2 root h integral from 0 to h of x 3 over 2 dx. And when you do this integration, you're going to get a 2 over 5 x to the 5 over 2 evaluated from 0 to h. And the 2 can cancel with the 2 in the denominator out front, so you're going to be left with 1 over 5 root h times h to the 5 over 2 minus 0. And once again, h 5 over 2 times h to the minus 1/2 is equal to h squared. So you get h squared over 5 as the expectation value of x squared. So now we're finally ready to plug this in to this standard deviation equation right here. So let's go ahead and do that. This equation, once again, is the expectation value of x squared minus the expectation value of x quantity squared. So we found that the expectation value of x squared is h squared over 5, and the expectation value of x quantity squared is h squared over 9. So if you find a common denominator here, you multiply this by 9, that times 5, you get 4h squared over 45 square root. And then that can simplify to 2h over 9 times 5, and if you square the 9, you get 3 root 5. This is the answer for part A.